Now I want to talk about special vanishing points. Come on. Sometimes you may need consistent shapes that aren't squares. This is where special vanishing points come in. Special vanishing points and diagonal vanishing points are similar. However, diagonal vanishing points only occur at the 45-degree angle. It's, you know, something. It's virtually the same thing, really. Continue drawing lines. Vanishing points, VPs. So when these the left and right vanishing points meet, just like diagonal vanishing point meets, they create this line. And where these intersection lines meet, a line is created which goes down to the horizon. And when this reaches the horizon, this becomes your special vanishing point. What's the difference between diagonal and special vanishing points? They're practically the same thing. Only special, as I mentioned before, diagonal vanishing points only occur at 45-degree angles. It's basically like the difference between right angle, obtuse angle, and an acute angle. It's virtually the same thing. Now if you continue drawing lines based on vanishing points and special vanishing points, you will get a grid allowing you to use as a guide to build convincing drawings, just like the diagonal ones. Actually, I guess I sort of demonstrated the special vanishing points with my previous thing, but this is like more specifying special vanishing points. The other one was specifying that. Remember, align to the outside grid, so it'll be more accurate. Then special vanishing point, special vanishing point, left and right vanishing point, special, special, left and right. Special, special, left and right. This thing's not cooperating with me. It can be a little tricky and confusing because you can have so many lines going everywhere. Well, what you can do is use different colors to differentiate them. The trick is, once the initial square is established, use the special vanishing point to draw lines adjacent to the square and then intersect the vanishing point lines with a new special vanishing point lines. draw a little corridor over there, trying to like make a little hallway using vanishing points. Then maybe do like a door frame here, and that goes over here. If this door frame is here, then these vanishing points say that it aligns to here. And if these vanishing points are aligning the door to this edge here, then that door frame edge is aligning to this point here. And if the door frame is aligning to this point here, then if there are any other doors over here, then the top of any other door over here, any other door would have to be about here. So we can put like another door here, and the height of this door should be equal to the height of the other door over there. That's how you use vanishing points in a complex scene. I feel like I just said something like random and unexpected and confusing. If there's like a ceiling grid pattern, like kind of like this, and there's like anything in the wall, like I don't know, light fixture or vent, you can use the grid to figure out what it's supposed to look like, or the orientation of the light fixture or vent. And that's the application. That is another application of vanishing points and special vanishing points and diagonal vanishing points and whatnot.